Assalamualaikum students. Students, today we are starting chemical bonding. Now, you know what is chemical bonding? Chemical bonding are the forces of attraction that holds the particles together, like they bond the particles. Now, there are three types of bonding in your course. One is ionic bonding, one is covalent bonding, and one is metallic bonding. You can see the periodic table on the screen. Now, if you look at this periodic table, hydrogen is non-metal. Hydrogen is what? Non-metal. Right? And you know, below aluminium, if you make a staircase roughly like this, like it's not exact, but I know that below aluminium, all these are metals, and all these are what? Non-metals. Between metal and non-metal, the bond is ionic. What? Below this staircase of aluminium, these are all metals, and these are all what? Non-metals. The bond between the metal and the non-metal is ionic. Between non-metal is covalent. Between metal is metallic. Like if I ask you, then what is the bonding in zirconium? Metallic. Calcium, metallic. Ruthenium, metallic. Zinc, metallic. Bond in chlorine, chlorine with chlorine, covalent. Chlorine with sulfur, covalent. Like for example, SO2. S is a non-metal, O is a non-metal, covalent. H2O, non-metal and non-metal, covalent. PCl3, phosphorus and chlorine, covalent. Scandium with nitrogen, ionic. Potassium oxide, ionic. See? These are the notes. These are the notes of the chemical bonding. These are all available on my website, Chemistry by Zeenat, right? So for the notes, you are supposed to go there. But right now I'm explaining that what are these different types of bonding and how you will differentiate. And what is, then I'm going to explain each and every one in detail. But right now, the first thing, see, chemical bonding, three types: ionic, covalent, and metallic. Ionic, between metal, non-metal. Covalent, between non-metal. Metallic, between metal. Now, the first thing, between metal, non-metal is ionic, but in non-metal, covalent, in metal, metallic. First thing that you must know that which one are metals and which one are non-metals. See. Look, what I have written? All these below the staircase is what? Metals, non-metal. So between metal and non-metal, ionic. Between non-metal, covalent. Between metals, metallic. Now look. Sodium chloride. Sodium is group 1, group 7, ionic. Aluminium oxide. Metal, non-metal, ionic. NCl3, non-metal with non-metal, covalent. Like, you must have a good command on these things. Like molybdenum, like if I give you example of chromium oxide, metal, non-metal, ionic. Phosphorus, P4O10, covalent. Now, boron trichloride. What is the bonding? Covalent. Strontium with phosphorus, ionic. Strontium with oxygen, ionic. Strontium with fluorine, ionic. Now, what is ionic bonding? How you will define ionic bonding? Ionic bonding is electrostatic forces of attraction between cation and anion. The definition that you people usually do in O1, in O2, that it is the bond that is formed by the complete transfer of electron. No, it's not the exact definition. If you will see the mark scheme, how they define it and what is the perfect definition, the electrostatic forces of attraction between cations and anions. Electrostatic forces of attraction between cations and anions. Between cations and anions. But how the cation is formed? How the anion is formed? They are formed by complete transfer of electron from metal to non-metal. Look, electrostatic forces of attraction between cations and anions. Ionic bond is formed between metals and non-metals. The metal lose electron, they make cation. The non-metal gain electron, they make anions. The cation and anion form, they attract each other. The cation and the anions, they arrange themselves in what? Giant ionic lattice. This is regular arrangement of alternating cation and anion. Regular arrangement of alternating cation and anion, cation and alternating, look, regular arrangement of alternating cation and anion making giant ionic lattice. Cation, anion, cation, regular alternating arrangement of cation and anion. So what is ionic bond? The bond formed, in which there are electrostatic forces of attraction between cation and anions that are formed by complete transfer of electron from metal to non-metal. The metal lose electron, the non-metals gain electron. Now, if you look at this structure, can you see that it's a big, huge structure like this or this? In this, the green one are chloride, the purple one are sodium. So cation, anion, cation, anion, cation, anion, cation, like regular alternating arrangement of cation and anion. Cation are positive, anion are negative. There are electrostatic forces. This ionic bond, this whole structure is called what? Giant ionic lattice. If you look at this giant ionic lattice, what should be the properties? The charging is very low. Wait a minute. It's charging now. Now, see, if you look at this structure, it's a huge structure. Is there one ionic or network of ionic bond? Network of cations, network of anion. It's a network of ionic bond. It's not just one bond. There is many bonds, many ions, but yes, they are regular alternating arrangement of cation and anion. In this structure, there are strong electrostatic forces of attraction, right? So they need a lot of energy to break all these bonds, Therefore, they are what? Hard crystalline solids, high melting and boiling point, high density, compact arrangement, compact. right? So strong electrostatic force of attraction between cation and anions need a lot of energy to overcome. Therefore, they are hard, crystalline, solid, high melting, high boiling point, high densities. Yes, they are made up of cations and anions, which are charged particles. These charged particles are vibrating at fixed position in solid. Vibrate, 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 vibrate. They're not freely moving. There are ions, they are charged particles, but these ions are not freely moving. So in solid state, they don't conduct electricity. They are charged particles, but they're not moving freely. Right? If the charged particles like proton, electron, cation, anion, if they're just vibrate, they're not moving freely, they will not conduct electricity. They're not charged carriers. They have the charge, they are charged particles, but they're not moving. They don't carry charge there. Like they can't transfer the charge from one place to another place, which is requirement of conductivity. For a conductor property, for a conductor, the ions must move from one place to another place, right? So these are ions, they are at their fixed position. The ions are the ions are just vibrating, they're not moving freely, they don't conduct electricity in solid state. But when these ions move freely, when they will move freely? When they're in water. What do you call your water? Mineral water. They contain minerals. Have you ever read the label on the bottles, water bottles? There are ions, potassium ions, sodium ions, chloride ions. These are ions, like the water that we drink, not the distilled one, the mineral water, the one that we drink, right? That contain many mineral ions. They contain ions, like they're aqueous solution of ions, right? So the ions are freely moving, they conduct electricity. Have you ever heard of electrolyte? Electrolyte, the electrolytic water. The people who do exercises, weight loss, and like in many these cardio type of exercise, they use these electrolytes. They drink to maintain the balance of the ions, and they perform good. Like these are needed. These ions are needed, the required one, but not everyone. Like too much sodium ion in water, this will increase your blood pressure. So they are linked like with these things. Health issues are sometimes, some are beneficial, some are not good. So leave this topic. The point is, if the ions are fixed, not conduct. But if the ions are moving, they will conduct. How to make these ions to be moved? To move. Put them in water. If they dissolve, the ions will start moving freely in water. If you melt it, the ions will be moving. When the ions are moving, it will conduct electricity. So when it is molten or aqueous, it's a hard crystalline solid, high melting, high boiling, high density because of strong electrostatic forces of attraction between ions. No intermolecular, nothing like this, just electrostatic force of attraction between ions, right? So since they're very strong, it's hard, high melting, high boiling, high density, and they don't conduct in solid state. Why? Because the ions are not moving freely. They are, but they're not moving freely. But when they move freely, like when they're molten or aqueous, it will conduct electricity. So ionic compound have which bond? Ionic? Structure is what? Giant ionic lattice made up of what? Ions. 3 points. Bonding is ionic. Structure is giant ionic lattice. Particle is what? Ions. Ions. Sometimes you people say ions. And we, old people, we say ions. Right? You people say ions. It's okay, perfect, good job. Next, dotted cross diagram. So, should I repeat all these? I think it's sufficient. You understand that what is ionic bonding? What is ionic bonding? Strong electrostatic forces of attraction between cations and anions. Cations are made by loss of electron, anions are made by gain of electron. When metal lose electron, they make cation. When non-metals gain electron, they make anion. The cation and ions, they arrange themselves in what? In giant ionic lattice. What is giant ionic lattice? Regular alternating arrangement of cation and anion. They are hard crystalline solid, high melting and boiling point, high densities. They don't conduct electricity in solid state, but they do so in molten and aqueous because the ions will be freely moving. Now, dotted cross, you can see this. Ionic bonding and magnesium oxide. What is happening? This is magnesium. What is the electronic configuration? 282. It will lose the 2 electron. It will lose the 2 electron. To complete the last shell, you know this. When it loses the 2 electron, it is what? 2 and 8 with 2 plus charge. Huh? Look at magnesium. Magnesium has 12, 2, 8, 2. It will lose the 2 electron. And oxygen is what? 8, 2 and 6. It will lose the 2 electron to this. So it becomes what? Plus 2. It becomes what? Minus 2. It is losing. I think, okay, one mistake that I made in the notes is this should be crosses. So these are dots. It gives 2 electrons. So each magnesium will lose how many electrons? 2. Why? To complete the last shell. And each oxygen will gain how much electron? 2 minus 2. Right? So when it loses 2, it gains 2, it becomes 2H, it becomes 2H. They attain the configuration of group 0 noble gas, group 8. This is what? Group 8. Right? Like neon. You know what is neon? Neon is 10, 2 and 8. So their configuration is now 2 and 8 and 2 and 8. The rest is not like neon. Their proton and neutron are different. Only the electronic arrangement of Mg2 plus, the electronic arrangement of Mg2 plus, the electronic arrangement of O2 minus. They are what? Identical to that of neon. Now, if you see sodium chloride, sodium is what? 11, 281. Chlorine is what? 17, 287. What it will do? It will lose 1. It will gain 1, become 8. Huh? It becomes what? 2, 8, like neon. It becomes what? 2, 8, and 8, like argon. You know? Neon is what? 10, 2, 8. Argon is what? 18, 2, 8, 8. So chloride become like argon. Na become like what? Neon. Na plus becomes like what? Neon. It loses 1, it gains 1. Right? So it become what? Plus 1. It become what? Minus 1. Next. See? Calcium chloride. You know how is calcium? 20. 2, 8, 8, sorry. 2. And chlorine, you know, 287, 287. Now what is happening? It will lose 2 electrons. It gives 1 electron to 1 chlorine, another electron to another chlorine. What is left? 282. Like what? Argon? Huh? 288 is argon. Argon is what? 18. Argon is what? 18, 288. It also becomes like argon configuration. 18, 288. Each calcium lose how much? 2. Each calcium lose how much? 2. And each chlorine gain how much? 1. So calcium is losing 2 electrons, 1 to 1 and 1 to another. So it becomes what? 2 plus. It becomes what? Minus and minus. If you see. It's what? Lithium. It will lose one. The other lithium will also lose one. Lithium is what? 3, 2 and 1. It will lose one. So one lithium loses one lithium, another lithium loses another. Huh? And oxygen is 2 and 6. Need how much? 2. So one lithium is giving electron to this and the other is giving to this. So each lithium loses 1, each oxygen gain 2. So when each oxygen is gaining 2, so it will give 1 electron and 1 electron. So it becomes what? Plus and minus 2. So it's what? Li2O? Yes. It's what? How many lithium? 2. Li2O. You can even think like this. Li plus O minus 2. The 2 comes down. The 1 comes down like this. I hope you understand the ionic bonding. These ions are formed. The ions arrange themselves in what? Ions arrange themselves in crystalline lattice. Huh? Regular arrangement of alternating cation and ions. Cations are made by loss of electron by the metals, and ions are made by the gain of electron by non-metals. The metal lose, the non-metals gain, they arrange themselves in such crystalline lattice. Therefore, it's what? Hard crystalline solid, high melting, high densities don't conduct in solid state, but do so in molten and aqueous, when the ions would be freely moving. I think, students, it is sufficient for today. In the next lecture, I'm going to do what? Covalent bonding with you people, right? Now, what you are supposed to do? Don't forget to like, subscribe, and share my channel, right? And for the notes, you can go to my website from where you can find these notes. And if you want to join my live session, you can contact on my WhatsApp numbers. See you till next lecture. Allah Hafiz.